Hi everyone, thanks for listening to my presentation for EDST544 Assignment 2B, Scientific Investigation. My name is Gabrielle Ryan and my presentation today is on investigating our circadian rhythm. So what is our circadian rhythm? So this can influence our sleeping and our waking cycles, the hormones released by our body, how we digest and eat food and our eating habits, our body temperature, reaction speeds, and other important bodily functions. So other terms you might have heard to describe our circadian rhythm might be our biological clock, our body clock, circadian clock, anything like that. But basically the body's master clock controls the production of melatonin. So this is a hormone that makes you sleepy. It receives information about incoming light from the optic nerves in our eyes and relays that information from the eyes to the brain, a particular part of the brain called the hypothalamus. So when there's less light, like at night, the hypothalamus tells our brain to make more melatonin so you get sleepy and get ready for bed. So researchers at the moment are also studying how people like shift workers, as well as exposure to light from mobile devices, which is a common thing these days, can actually impact on our circadian rhythms and on our sleep-wake cycles. So why are we interested? So biological clocks that run fast or slow can result in disrupted circadian rhythms. And these sort of rhythms that are disrupted or abnormal have been linked to various chronic health conditions like obesity, diabetes, sleep problems, depression, and other mood disorders like bipolar. So it is important to better understand how our circadian rhythm works and how we can support a healthy circadian rhythm. And that means supporting healthy sleeping habits and minimising the risk of developing these sorts of chronic diseases. So here's an example of what a typical circadian rhythm might look like. So as you can see, starting at midnight down at the bottom of the screen, we've got our deepest sleep at about 2 a.m. We're moving up to about 4:30, our body's at its lowest body temperature. We go on and our melatonin secretion stops in the morning at about 7:30, and then we start sort of waking up and reaching high alertness mid-morning about 10 a.m. As you can see, we have our fastest reaction times at about 1:30 in the afternoon, 3:30 in the afternoon, and our highest body temperature at about 7 p.m. in the evening, and our melatonin secretion starts at about 9 p.m. So our core body temperatures, I've pointed those out as they're actually a good way of charting our own rhythm, because energy can sometimes really well reflect our temperature. So our body temperature isn't a static 37.5 degrees. In fact, it does fluctuate throughout the day. So that's in line with our circadian rhythm. But of course, it is also affected by, the temperature in the environment around us and whether we've been active during the day, like run up a flight of stairs or gone out for a jog, that type of thing. That would mean our body temperature would just naturally increase. So with all that in mind, I've decided to ask the question, can our body temperature and reaction speed tell the time of day? So the aim of my investigation was to find out how the human circadian rhythm works by measuring how body temperature and reaction speeds vary throughout the course of a day. So I found this picture, it's a bit blurry, sorry, of what a normal rhythm might look like. And here it's measuring energy levels, which can, as I mentioned, be an indicator of our temperature levels. So here there's a peak and a big trough, and a big peak. So we're meant to have our highest energy levels sort of in the afternoon to early evening, and then it's slowly decreasing as the night goes on. Our lowest energy levels, obviously, between midnight and the morning where we're fast asleep. So let's just see how my results to track along compared to that. So to carry out this investigation, I set up a 3-hourly schedule to measure my body temperature and reaction times each day over a 3-day period between the hours of 8 and 11 p.m. So at the first time interval, the thermometer was placed under my tongue and held in place as per the thermometer's instructions for approximately 20 seconds, and then a reading was displayed. So the temperature was recorded to the nearest 0.1 degrees Celsius, and this was repeated until 3 readings were recorded for each time interval. So an average temperature was then calculated based on those results. So that's the exact same, that's me holding my thermometer that I was using after I tested one day. Following on from that, I tested my reaction speed. So I did this using an online tool from topendsports.com. I just did a Google search and this is one of the results that came up. Very simple test. I tried to manage the light and sound levels each time I took my test to make sure that they were similar or the same during all the reaction tests. Before I recorded any reaction times, I did a test trial and then 3 attempts. So I recorded each result and averaged the reaction speed for that time interval. So I completed those steps 2 and 3 at each time interval, so every 3 hours between 8 a.m. and 11 p.m. over those 3 days. Recorded those results and average those out, as you can see in my spreadsheet below. And I compared them to the circadian rhythm chart. So here's my results, and they are interesting because they weren't what I expected. So in the morning, so I obviously didn't measure as early as 5 a.m, which would have been helpful to see how I was very first thing in the morning, but first reading was at 8 a.m. and that was actually my highest temperature over the 3 days, was first thing in the morning. Now, it was interesting because it was quite hot in Melbourne during that week, so I'm not sure whether that's got anything to do with it. And it might have been when I was running around getting ready for the day, so perhaps there was a bit of movement going on, but that was consistently my highest reading. My lowest temperature was recorded between 5 p.m. and 6 p.m. each evening, and that is pretty much, that's the lowest temperature is meant to be in the middle of the night, where in a period where I didn't actually measure, so that's an interesting finding. Now, the difference between my highest and lowest recorded temperatures was 0.2 degrees. So my highest temperature was 36.6 between 8 and 9 in the morning, and my lowest was 36.4 in the middle of the day. And then, as you can see, at 8 and 9 p.m. it peaked again and then started to go down as the night progressed. And I imagine if I kept recording my measurements during the night, that would have gotten lower and lower and lower until we reached the morning. So then I tested my reaction speed, and this was interesting. So I wasn't as surprised with these results. So my quickest reaction time was about between 2 and 3 p.m, which is in line with the chart here. As you can see, fast reaction time is meant to be about 3:30. So that's very much in line with what was expected. And my slowest reaction speeds were between 10 and 11 p.m. and 8 and 9 first thing in the morning. So as I'm a little bit sleepier, a little bit more tired, those reaction times increased. But you would have thought, looking here at 8 and 9 a.m, I had my highest temperature, didn't necessarily mean I was the most alert at that time. So the difference between the fastest and slowest recorded reaction speeds is 0.263, which is pretty interesting. I think that's fairly significant. So the quickest was 0.36 between 2 and 3, as I mentioned, and the slowest was 0.623. So I think that's a fairly distinct difference between those reaction times in those periods of the day. So interestingly, my lowest body temperature was mid-afternoon, and the possible reason for this might be cultural influences. So, for example, in my readings, I found that perhaps this is due to cultural reasons, such as, Latin America people have siestas in the late afternoon, the UK drink a lot of tea in the afternoon. So perhaps there's something our body's reacting to those cultural influences that have occurred throughout the ages. Also worth making a point of at this point is the accuracy of the data which I obtained. So there were definitely some points where there could have been some errors made in the data, particularly with the use of the equipment. So the reaction test the reaction test online wasn't validated. I'm not sure how reliable it is. So perhaps next time it would be important to use a reliable and validated tool to better get some accuracy into my reaction times. Also, my thermometer, it didn't measure something that would be helpful if it measured a more accurate temperature. So it only measured 2.1 of a degree Celsius. So something more accurate would be helpful in terms of determining body temperature changes throughout the day. Also testing more regularly. So being able to test throughout the evening and early in the morning would have provided us greater insight into my circadian rhythm. Also, worth noting, it was very hot in Melbourne that week, so environmental temperature effects may have affected the readings. I'm an active person and often get up and move around during the day. I didn't sit still all day, and there were moments where I might have been up wandering around and then decided, oh, I've got to take my measurement, and took the temperature without letting my body sort of just settle, which might have affected the result. Also, I try to be pretty careful, but I do drink a lot of hot drinks during the day and cold drinks as well, so this can also affect the test. I was pretty careful not to do that just before taking my temperature, but this is something that could also impact results. So that's all. They're all things to keep in mind. Also, artificial lighting. So I'm often on my phone first thing in the morning and then late at night, like many of other people, I'm sure. So I wonder whether this also might have had an effect on my temperature first thing in the morning, which was quite high. So thank you for listening. It's been an interesting insight into my circadian rhythm and why it's important to make sure that we try and adapt our surroundings and ensure that we can maintain a good circadian rhythm to help our sleep and reduce the risk of developing chronic disease. Thanks for listening.